Hi, everybody. I hope everybody can hear me okay. And so the next step after getting the interface up and running and just learning how to assign variables and do some basic variable initializations is to understand how to play around with them a little bit. And probably as a precursor to more sophisticated programming constructs, we need to know how to operate on variables. The minimal thing that you want to be able to do is be able to use the computer as a calculator. So that's where we get into the notion of arithmetic operators, because you want to do arithmetic. That's the most basic thing that you would want to do on a computer. Well, I take that back. There's really two things. Historically, it was either for computers were either for calculations or they were for data processing of string and character data, or a mixture of the two. And so we'll first get into our arithmetic operators and then talk about relational operators, because oftentimes we're really going to need to do comparisons, and then finally logical operators. So we'll dive right in. And so probably the best place to go is the course itself, which is Unit 2 on operators. And I want to preface this. I'm sure that you all know how to use a calculator, how to add, subtract, multiply, and divide. So those operations really aren't too difficult to absorb. When you go into different computer languages, the idea of taking a number, so plus, minus, star is multiplication, and the slash here is division, typical division. And then we get to exponentiation, which is 2 stars. So if I wanted to say something like 3 squared, that I would write 3 star 2 like this. That would be the syntax. Okay. And I just want to, so hopefully everybody has this down. And I had a question yesterday. And again, like for me, having done this for so long, it's easy to forget. It's easy for me to forget like the initial kinds of mistakes, unless I teach at the introductory level, the kinds of mistakes that could be made. But I had a student yesterday, and I don't want to embarrass him. I wouldn't want to say his name, but I'll give his phone number and address at the end of, no, I'm just kidding. But I had a student who had a question, who was trying to program the law of cosines. And the equation goes something like this. And this speaks to exactly one of the major things, that's when somebody starts out, okay, times the cosine of some angle, call it, I'll use a letter. I won't use like a Greek letter. I'll use like a letter G. So assuming these variables have been initialized, assuming that C were known, A were known, and B equals 10, C equals 3, A equals 5, simple instructions like that. He wanted to solve for the cosine of G. And so this is the law of cosines. Whether you know that, if you're trigonometry, it's irrelevant. This is just an equation. What's important is that this is a mathematical equation, and this is an equal sign that describes equality. And so if you were doing this in Python, and other languages would use, and that's another point you need to bring up, is that different languages use different syntax for exponentiation. But what he was trying to do, I'll try and translate it to Python. It was a different language, but he was trying to translate the equation into this. And this is what he had effectively in his program, in his code, like this. So that's an A, and then plus B star B minus 2, blah, 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 blah. And he was trying to keep a faithful reproduction of the mathematical equality. And he programmed it up like this. But this, my friends, is an assignment statement. And I was trying to show him that you need to have a bucket or a variable over here, call it Z. And then Z, you're going to have to understand as carrying whatever is on the right side of the equality sign. So it goes in this direction. But I'm trying to bring out the error that I saw this person make, because it's fundamental. It was very basic, but it was causing him to not get his code to work correctly, because he was trying to draw a one-to-one equivalence between the equation and the syntax of the programming language, which is completely disallowed. And because you can't have anything on the left side of the equal sign that would represent a mathematical equation. It just has to be a variable. There are variables on the left and there's stuff on the right, and the stuff flows on the right into that bucket on the left. And so so as a review from last week and as a lead into this week, because we're talking about operators like exponentiation, for instance, I just want to be clear that one of the goals of programming is, in fact, sometimes you do have to take an equation and translate it from the mathematical form into its specific language syntax, into those language constructs. And sometimes there isn't always necessarily a perfect one-to-one translation between those things. And that's part of what I want to talk about in these few minutes. So if we go back over to, let's say, the replit window, I think the operators, let me come back over here again. Let me clear these drawings. Two of the operators, so again, I think you all understand plus, minus, multiplication, and division. Two other operators, this is called integer division, and this operator is the modulus operator. What you get from integer division, and this is where you got to be careful going. Sometimes students accidentally fall into Python 2, and there are slight differences between Python 2 and Python 3, and it has to do with this division operator. And this syntax was developed specifically to handle if I wanted to divide the number 7 divided by 2, but I want to throw away the decimal part. And we all know 7 divided by 2 is 3.5. So you would expect a floating point answer from this, right? But in this case, what happens, instead of 3.5, you'll get the number 3, and then we throw away the decimal part. So this is an integer operation, and the answer that you get out of it is inherently integer based. It's not a floating point number. This division operator will get you floating point numbers. And again, I don't have time to go into the whole history behind that, but Python 3 addressed the issue of division in Python 3. And the percent operator is just the remainder after dividing by a number. So if I say like 21 mod 4, okay, this is equal to 21, the remainder of 21 divided by 4, which is equal to 1. Or 27, let's say, divided by 5, the remainder would be equal to 2. So that's what the modulus operator gets you. So it's important to see the interplay between these two operations, the double slash and the percent operator, because one gets you the integer part of a division and the other gets you basically the remainder of an integer division. So they're inherently integer-based operations, and you need to pay close attention. If you're using the double slash, you're really being intentional about using integers. And similarly for the modulus operator as well, that tends to be, like I said, you can redefine it in ways where you could probably handle something within floating point, but we don't need to go down that path. The point is that the percent operator and the double slash are meant to be, they were designed to be integer-based operations. And then one last thing about the modulus I want you to recognize is that it forms I'm not going to go into the math behind this, but too much, but it forms a congruence. And so if I'm counting with integers, and maybe I'm going to make this 0, and that's -1, -2. This is important to understand because different languages actually do different things with this percent operator, and it can be a little frustrating at times. And again, I don't have time to go into all the differences, but Python actually does compute the true modulus, the true remainder according to the definition of what are called mod congruences. And what that means is that if you have integers, make believe, and I'll say that you're counting from a very negative number to a very positive number, and I'm interested in computing numbers mod 3, okay? So 0 mod 3 obviously is 0, 1 mod 3 is 2, 2 mod 3 is, the integer division of 3 divided by 3 would give you a 0 back again here. 4 mod 3 is 1, because 4 divided by 3 would give you a remainder of 1. 5 mod 3 would equal 2. But this forms like a periodic sequence, and this is how the definition of the modulus works, is that if I attempt to compute, for instance, -2, so this would be mod 3 or percent 3, mod 3 in Python, this would translate into percent 3, that -2 percent 3 will give you a value of 1. And that's not, again, I don't have time to go into all the differences. That's not necessarily true in every language, oddly enough. Python really stays true to the notion of what's called a congruence. And the congruence basically takes the integers and wraps it around periodically around these digits 0, 1, and 2 for the case of mod 3 So all I'm trying to say is that for those of you who understand what I'm saying, this is a true modulus operator, and I'll leave it at that, okay? So that's all I want to say for initial introduction to arithmetic operators. If anybody has a quick question about anything about arithmetic operators, I'm going to go on to the next idea that I want to present to you.
Yeah, the chat does not currently have any questions for you. I do. First of all, I would like to say, very humorous. You're like, everyone knows 7 divided by 2 is 3.5. Everyone but one person. And the other question I was going to ask you, and this is maybe covered in the course, but I thought we could talk right here. When you say Python 2 versus Python 3, you're talking about the versions, correct?
Yes, so Python 2 was an older version of Python. We are in Python 3, and again, there are slight subtle differences when it comes to the print command and also integer division. And so I don't want to go too far down the path of what those differences are. Suffice it to say that Python 3 has two division operators, one for floating point divisions and one for integer divisions.
Excellent. I think I'll see if anyone has any questions in the chat, but for now, I think we can move on.
Okay, great. So the next thing that happens sometimes more at the introductory level is if I define, let's say, a bunch of numbers, let's say b is equal to 2. And so if you want to follow along in Replit and try and type this in, it's a great idea. C is equal to 4, D is equal to 8, and I don't know, E is equal to, I don't know, 7. Okay. The key thing to recognize is that, like, when you're writing equations, and this has to do with the order of operations, or what's called operator precedence, they follow the basic algebraic rules that you would expect, or that you might have learned in like an 8th grade algebra class, is that you perform multiplications before additions, you perform exponentiations before you perform multiplications and divisions. And then if there are parentheses, the rule is whatever's in the parentheses you do first. So if I would write something like a plus b divided by c, for instance, I'm sorry about that, I'll do it like this, I'll print it out right away. A plus b divided by c. What your eyes should be doing is they should be scanning from left to right. And then, of course, you probably learned that, maybe you learned the term PEMDAS. That's a very common type of a term to say parentheses before multiplication and division before addition and subtraction. So you look at this expression and you look for where all the multiplications and divisions are, and then you perform the additions afterwards. So in this case, you would first divide b divided by c, which is a half, and then whatever a is, you would add to it. So back to that number, oddly enough, 3.5. So that's, oh wait, I'm not sharing. I got to share the right screen. I'm so sorry. This happens sometimes. Apologize.
Yes.
Replit.
Yep. Yeah, there you go. Yep, back there.
Okay, so b divided by c is performed first, and then the a is added second. So if we go ahead and run this, then we should see the number 3.5. And so if you wanted to, if that isn't what you wanted to do, maybe you wanted to add the numbers a plus b first. If you want to do that, then you've got to put parentheses in there to do the addition first, right? To override the basic language construct that obeys basic rules of algebra. So in this case, you're saying you actually want to add the two numbers first and then divide the c. And this is probably most important if you're ever going to do any programming where you use with long numerators and long-winded denominators. And so if we run this, then of course you just add a plus b and then divide that by c. So now you'll get 5/4, which is 1.25. But the thing is that probably the most common error that I've seen sometimes is if you wanted to do a plus b divided by c plus d, something like this. Oops. And with regard to the order of operations, excuse me, this is going to first take b divided by c, again, which we already agreed was a half, add a plus a half plus d. And if you add a, which is 3, d, which is 8, and then you add the 0.5, you would get 11.5. If you didn't want to do that, like probably oftentimes what I see sometimes is that people say, oh, I was trying to program a fraction to do this. I wanted to add the numbers in the numerator first, and then I wanted to add the numbers in the denominator second, and I wanted to divide those two numbers. Under those circumstances, you've got to be intentional about those calculations. And that's really what I mean by trying to stay true to an equation, because sometimes with equations, this isn't always true. Like you might encounter something that might, while you're reading something, say, oh, program this up, program a plus b divided by c plus d like this. And when you do that, you've got to translate this over into Python, Python syntax. And of course, that's where you'd have to add the two numbers in the numerator first, and then divide the two numbers in the denominator second. And then Python's smart enough to know by its order of operations that you want to do the division of those numbers that are summed together within the parentheses. So it's a subtle point, and it's not difficult to understand, but I'm just saying syntactically, I've seen these are the kinds of errors that happen not because someone doesn't understand the order of operations, or not because they don't understand how Python processes the order of operations. In the mental conversion from an equation that one reads on a piece of paper to actually writing the syntax for implementing that equation, sometimes these little types of mistakes arise just because one forgets, oh, you figure it out at some point. You need the parentheses somewhere to make the calculation do what you wanted it to do. So there's a certain measure of intentionality when it comes to using parentheses. Now, sometimes when students start out, they'll start writing expressions with like parentheses all over the place just to be safe. And that's going a little bit too far on the other end of the spectrum as well. So you want to have a balanced approach. Like for instance, make believe that I wanted to take like a squared plus b squared, okay? Here's a case where I'm going to compute a squared plus b squared. And when I do that, I'm going to get the number 13 because 3 squared is 9 and 2 squared is 4. Now, what would happen if somebody were first starting out because they might be concerned about the order of operations? They might intentionally say, okay, I'll put parentheses around the a squared, okay, just to make sure that the exponentiation is done first, and then maybe make sure and put parentheses around the b squared just to make sure that the exponentiation for b is done as well first. But this is unnecessary. So sometimes parentheses fall into expressions that are unnecessary because we know from the order of operations that Python will perform the exponentiations long before the additions ever take place. It's not incorrect. It's not incorrect syntax. It will actually work. But again, it's like when you start to get expressions with 20 sets of parentheses to implement something, you got to take a look at it and say, do I need all these? So there's like a balance between readability and functionality. Okay, that's about all I'm going to introduce for arithmetic operators, just because of the amount of time we have. But I'm happy to entertain any questions about integer divisions or modulus or order of operations for arithmetic operation at all.
I would like to say the algebra thing. I never considered that it was blew my mind. I'm learning so much. I don't know if I have a question related to, but we have a question here in the chat, which I Googled. So to make sure, good question, but it was asking about your IDE or integrated development environment.
Yeah.
They were asking to know more about yours specifically.
Okay, it depends. Like oftentimes I'll usually teach with Replit, and I'll use Replit if I just need the quick and dirty, I'd like to test this out, or I want to test that thing out. If I'm trying to communicate more research types of things, I'm more inclined to use Jupyter notebooks that uses Anaconda Python 3. So Jupyter, Jupyter, is another one that people use all over the place. So this is easy to find. Again, sometimes with any type of installation, there are always potential issues with regard to paths and setups. And in an ideal world, these types of installations, should go seamlessly. But I have seen small 2 or 3% of the time when one does an installation, sometimes Anaconda will get confused about where it's looking for files and so forth. If somebody makes some assumptions or does something during the installation because the paths weren't set up correctly, it's all fixable. But I just don't want to introduce those kinds of headaches in an introductory course like that. That's really why I use this IDE. So Replit I use for either just testing small chunks of code here and there, just to have something quick. And then if I'm communicating larger results, Jupyter notebooks. And I was probably more into Microsoft Visual Studio for a while. And then, like I said, it just gets confusing jumping from one tool to another, but I still use it occasionally, but I probably lean more towards Jupyter notebooks also to communicate files and so forth. I hope I'm answering that question.
Awesome. I think you answered it for me. So I think that's pretty good. We can probably move to the next one. I'll let you know if we have any other questions.
Yeah, but sometimes computer scientists get territorial. It's all using that idea. That's a terrible idea. It's whatever. It depends. If you're doing
I know a couple of them.
Yeah, I'm sure you do. But I'm just saying, like for development, for going from soup to nuts with Python development all the way to a final standalone application, that's really not for this course. But you need a couple of extra hooks in place to get beyond Python scripts, by the way, because ultimately you want to, if you're writing applications, you want to convert that into low-level code that could be executed independently of an interface. So there's a whole pipeline that goes beyond just typical basic Python scripts. So this is very introductory stuff that we're doing right now. Okay, so I hope I answer that. All right, the next thing I would say, the next piece of information that you need to really be good at is just feeling comfortable with relational operators. If I set up the number a equal to 5, and again, these are not the most exciting variables in the universe, so don't, it is what it is. And if I wanted to ask the question, is a equal to b, this is where the relational operators come in, because you are no longer performing an assignment. You're not trying to talk about equality in the mathematical sense that you would be attempting to assign a variable using the equal sign. We're just trying to compare two values. And if we go ahead and compare them like this, then obviously a is not equal to b. You're going to get a false answer. So another data type, okay, that we need to discuss, if I haven't mentioned already, is the Boolean data type. It's whether or not something is true or false. And so Boolean data types, the type bool. So if I were to say something like x is equal to, watch this in slow motion now, I can set x equal to the result of that calculation. And then I can ask the type to tell me the type of that particular variable type. And the variable type, so far we know int, string, and float, and now we're adding bool to the list if I didn't do that last week. And so if I set b equal to 5, well, obviously they are equal, so I would get a true out of that. I could say print x here just to speed things along. So it would be true. So Boolean variables take on one of two. You're in a Boolean universe. It's one of two possibilities, nothing else. Something is either true or false, but not both. And it's as simple as that. There's nothing complicated about it. Now, I could ask if there are other relational operators you got to be comfortable with. Is it greater than or equal to? A is greater than or equal to b, right? But it's not greater than b. So a greater than b should be false at this point, because a clearly is not greater than b. A has been defined as 5 and b has been defined as 5. If I change b to a 3, and then this result would change to a true, because now a is 5 and b is equal to 3, and one is greater than the other. So the relational operators are a double equal, are greater than or equal, less than or equal to, and less than or equal to, less than, and the not equal. Okay, because we want to know. So a clearly is not equal to b, so that results in a true result. So so when you're using relational operators, very straightforward. You're just trying to determine the relationship between two variables. And again, once again, the rule is going to be the same algebraically. If it turned out, for whatever reason, you wanted to write a string of relational expressions, for whatever reasons you would have, that we're going to get to this in a second, because I'm going to add logical operators in a moment, is that the progression still is from left. The processor still is working from left to right when it sees more complex expressions. And so I'm going to get to that now. Now, where I'm going with all of this is that you've got to be, for next week, you've got to be like 1,000,000% comfortable with relational and logical operators, because they are instrumental to writing what we're going to introduce in terms of conditional statements and loops and so forth. I think it's next. It's either functions or conditionals. But at some point within the next 2 units, we are not going to be able to get away from having to be experts with relational and logical. So those really are the relational. That's where we are with this. It's greater than or less than or equal, greater than or equal to, equal, not equal to. See if I left anything out. That seems to be a good list for now. So let's go up like that. And that's all there is to it. The reason you're using these is because you're interested in the comparison between sets of numbers. So is everybody good with this? That's the second thing that I wanted to talk about. So I'm happy to entertain any questions whatsoever.
We have not had any new questions. I can say that next week's unit is input and flow control statements. And the week after that is data structures.
Okay, so the flow control is going to involve everything with input, with if statements and so forth. Okay, thank you so much for that. I know what should come next, but it's like my first day
I got to sound like I know something once in a while on these.
It's my first day on the job. Wait, I designed the course. What's wrong with you?
Also, I should have pointed out before, people found your other answer very helpful.
Okay, that's excellent. Good. All right. So the last thing that we want to do is broach the subject of logical operators. Sometimes in some texts, you'll see them call them Boolean operators. I refrain from using that because I don't want to get that confused with just the word bool, which I usually try to reserve for the data type. Again, it just depends on who's talking and what their language is and what they prefer to use. So you'll hear me use logical operators, and so those are the the logical operators not and or. So I don't know if I can overemphasize just at what point it's so important to know what these operations do, because I find so often that students get on the other side of that next unit still being a little hazy about what these operations do. So all a not does is just take the called the logical complement. Sometimes it's called logical negation. It just takes a true and turns it into a false, and it'll take any false and then turn it into a true. So if something is true, it'll become false, and if something is false, so it'll become true. So it's like the equivalent of arithmetic negation with a negative sign if you put a negative in front of it, but it's logical negation. If you put the not in front of a true or a false, you get the opposite. Okay, for the and the or. In the course, I'm not going to take the time to do this, but somewhere there has to be mention of a table of some kind that tells you what happens in the event. Let's talk about the and, let's say, in the event that you have true, let's say true, false, and false, and then true, false, and then true, false. So this is called a truth table. And if you take the and of a true and a true, you should always get a true out. In any other event, you should always get something that's false. So logically, the logical Boolean definition, according to Boolean algebra, and George Boole, who lived 150 years ago, longer than that now, and died about 1850 or so. And may he rest in peace. I don't know what I'm saying. The only way an and can be true is if both operands are true. And that, even though I would like you to learn this table, the most important thing is that when you write out conditional expressions, when we get to that point, you're going to see have strung together a bunch of different logical conditions, and you might be anding them and oring them. And so you want an immediate visual way of ascertaining the result of a logical calculation. Is it true or is it false? And the way that you do that is just by looking at two terms, for instance, that might have an and between them, and then you look to see if those two terms are true. If either one of them is false, you don't even need to check both. If you see one is false, you're done. Okay, it's false. The only way that an and can be true is if both expressions are simultaneously true. And that's the way I want you to think about it. Now, that's the intuitive understanding. For the or operation, it's different. It's a true, false, true. If you take the or between a true and a false, let's say, or a true and a true, this will get you a true. This will get you a true. This will get you a true. And then finally, the only way that you can get false from an or operation, it's a binary operation. It's an operation between two operands, is that if both operands are logically false, then the answer comes out to be becomes false. So the way that you're anticipating using ands, ors, and nots is like taking combinations of relational operators, for instance. That's a very common way to apply these. You can get tricky and do a lot of other interesting things, but at the initial stages, you would say something like maybe X is equal to A greater than B, or maybe I'll try something like this, or somebody come back here. Or, I don't know, 5 greater than 1 or something like that, okay? And I'll say A less than B here, so just to hit home with this. So if we go ahead and run this, let's print it out. If we go ahead and run this, we're going to get an answer of true. Now, A currently is equal to 5, and B is equal to 3. So A clearly is not less than B. So this first piece here of this expression, of this more lengthy logical expression, is clearly false. But this is true. So we take a false result and we OR it against a true result, then we expect that we should get a true result out. If we were to AND these together, okay, since the first condition is false and the second condition is true, then now we're going to be taking a false and ANDing it with a true condition. Under these circumstances, we should be able to predict that result is false. And so there's there's like an art and a science to evaluating lengthy logical expressions, because what I would say is this, is that if you're really interested in the subject matter more for a deeper discussion, you should study a tiny bit of Boolean algebra. That's like the crux of computation. If you oftentimes what can happen, for instance, is that you may write down a long logical expression and you might wonder whether that's equivalent to some other logical expression that doesn't look like the first expression. You could actually prove stuff like that using Boolean algebra to show that there's logical equivalence between one and the other. But right now, at the sort of introductory level, you just want to be at a point where you can mentally break down an expression like this. So as you're reading it, your eyes can ascertain whether or not you get a true or a false result from that expression. Okay, so that's really what's going on here. So are there any questions? So far, we've gone through arithmetic operators. We've gone through a little bit about relational operators for comparing values. And then, of course, now what we might want to do is take logical combinations of Boolean variables or Boolean expressions so that we can form more complicated expressions that can do more interesting things. But again, in order to do that, that implies that you understand the and, the or, and the not operations. So I'm happy to pause for a couple of questions because I want to say one more thing.
We don't seem to have any questions. We'll give everyone a chance, but I figured since it came up, I thought I would do some math myself. George Boole died December 8th, 1864, which was 156 years, 2 months, and 2 days ago. I thought while you were doing some math, I'd do some math myself.
Yeah. It's really amazing to me. I tell different students, it's so funny how he was just a mathematical philosopher. He had there was a guy, Charles Babbage, who had tried to invent a mechanical microprocessor. And they met, historically, according to history, they met maybe once or twice or something. And George Boole saw no connection, at least I think this is historically true, between what he was doing and this computer that Charles Babbage was trying to, the inference machine he was trying to build and invent, but he never built it. It was just too complicated for mechanicals. It was like a mechanical computer. Yeah. But George Boole was like instrumental. All that Boolean algebra is like instrumental for igniting the computer age, basically. Like we wouldn't be sitting and talking right now if it weren't for the algebra that he had created.
But he saw no relation. He was like, you crazy computers.
Isn't that crazy? Maybe a little bit. I'll bet you he saw some connection, but not enough to say, oh, if you combine these two motors in an AND operation, you'll get that kind of. There's nothing like that to say. Okay, anyway, back to the program. And okay, so the next question becomes, if you're going to have this whole list of possible operators in Python, what are the rules for their evaluation? It's very possible that in a computer program, you might see combinations of arithmetic operators and logical operators and relational operators. So what I just did, there was something very implicit that took place. And I did this on purpose because I wanted you to think about this idea, even in this expression. Nice job. Let's just make something up where we had something like this, let's say. And there's something implied here that I'm doing. And that is with the parentheses, I am asking Python to evaluate those relational operators, and then I'm evaluating the logical operator or next. Okay, so this is what happens again. So A is in fact greater than B, or 5 is greater than 1. And the question is, what would happen if I took these parentheses away? Could I do that? Would I be allowed to do this? Would it even make sense to do it? And the short answer is yes, okay? And so if the answer is yes, then we have to have a discussion in some sense about what the rules are for how these expressions would in fact be evaluated, okay? And that has to do again with operator precedence. So again, one of the final sections of the order of the intersection is about its precedence revisited, okay? And the reason it's being revisited is because by the end of that unit, we've introduced arithmetic operators, we've introduced relational operators, we've introduced logical operators. And now the question is, when we start taking combinations of these, who's going to win? Who's the winner in a string if you're reading from left to, for instance? And I don't mean a string variable, I mean just a stream of logical operations. So under these circumstances, what are the rules? What happened here? Apparently, I may not have needed those parentheses after all. Or did I need them? Was I doing this instead? Was this actually accidentally happening without me knowing it? Was this being computed, for instance? Believe it or not, there's nothing wrong with this. I don't want to necessarily go into what happens when you use logical operators with numerical values. You've got to understand a little bit more at the binary level what's going on to make a statement like this. And you may not want to do this, but this could be what's happening in the background, because maybe the logical operator is actually, if you leave out the parentheses, maybe the logical operator is being evaluated before the relational operators. So what are the rules? Okay, that's where in the course, when it comes to operator precedence, if we pop back over here, there's a table. And this is a very important table that it isn't so much that you're going to memorize this table, it'll become natural. And we're not going to be able to, in this course, teach everything that's on this list. For instance, you'll see that there are ands, ors, and nots. We're talking about those logical operators. There's also what are called bitwise values. In order to handle the bitwise operators, you need to know a little bit about the expansion of numbers in base 2 so that you understand what's taking place in numbers when you're using their bit representations. And so this course doesn't go into that at all. So for now, at the introductory level, the bitwise and, or, and not aren't going to be relevant, but they're on the list, and shifts as well. You can shift bits around as well. But, and I don't know why they made this table. So I would have flipped it upside down, because exponentiation, we'll get into indexing later in the course. So right now, for all intents and purposes, what you need to know for this unit, exponentiation has the highest precedence. And therefore, for some reason, they put it on the list at the lowest level, which can be confusing. But mentally flip it upside down. The next has to do with negation, which is, we're not thinking of subtraction or addition. Just when you negate something, the negation is going to take place first, which is completely legal to do. Then we have multiplication, division, floor division, or what I'm calling integer division, and the remainder, okay, which is the modulus operator, okay? Then we get to addition and subtraction. Then, watch this in slow motion. Now, this is very important. The relational operators come next, and then the Boolean operators come at the low end of the totem pole, okay? And we'll get to all this other stuff later as well. So for what we know from this unit, from exponentiation, then there's negation, then there is multiplication and division, addition, then subtraction, and then the relational operators, and then the Boolean operators, okay? So this is huge, okay? Because now when we come back over to the expressions that we have here, we know, okay, because of the operator precedence, what's happening is that the relational operators are in fact being evaluated before the OR operation, okay? Before the OR operation. Incredibly important that relational operators have a higher precedence than the Boolean operations. And that's what enables us to write expressions like this without fear of those values. You can know so little that you wouldn't care, but then as you start to learn more, then you think, oh, I wonder what would happen if I didn't put the parentheses in. Is this going to get which is going to get evaluated first? Those are the kinds of questions that arise as you start to write more and more code. So in this case, in fact, the a greater than b and the 5 greater than 1 is being evaluated before the OR. And that holds true for the and, really any combinations of expressions and so forth. Is it wrong to put the parentheses in? No. Again, you may want to make this, in this case, it's easy, but there might be readability reasons, documentation reasons to make your code look pretty that you might want the parentheses in there, but you don't necessarily, for the sake of readability, but you don't necessarily have to do it, because as experts now, you know that the relational operators occur before the, okay. And so something like this, though, let's say a plus b greater than 7, let's say, okay. So now your expectation is that if you wanted a logical expression to add the numbers like this, okay, then you'd be asking the question, is a plus b greater than 7? Is a greater than 7? So in this case, you would expect a true, because it is. And let's take the parentheses away. And again, of course, because of the fact that the addition takes place before the greater than evaluation. So even though the parentheses aren't there, okay, because of the order precedence, because of the order in which the operations are evaluated, the addition is going to take place anyway. Okay, so you wouldn't be taking b greater than 7 and adding it to a. Well, would you ever want to do that? Believe it or not, you might want to take, and Python's, funny enough, Python is smart enough to figure out what you mean sometimes. So in this case, watch this in slow motion now, is that b greater than 7, okay, is a Boolean value. So it's not, Python is going to assume that you know what you're doing, let's do it this way, let's say b less than 7, okay. So it's possible, so this is just one other subtle point. I don't want to go too far off on a tangent. There may be cases where you actually one day want to do something like this, and it's possible. And Python is smart enough to figure out, oh, I've got a Boolean variable over here, and I've got an integer variable over here. What I'm going to do is I'm going to upgrade the Boolean variable from 0 in this case. I'm sorry, b less than 7. So if there's a numerical conversion, if there's any sensible numerical conversion for Boolean variables, it would be true is equal to 1 and false would be equivalent to a number 0. So if b less than 7 is actually true, because 3 is less than 7, Python would understand what you're doing, that you actually mean to convert that Boolean value to a numerical value, which would be 1 in this case. And then a would be 5, and 5 plus 1 is in fact 6. So sometimes when you mix these expressions together, Python is going to take leaps for you because it thinks that you're trying to do some type of type conversion. And that's why it's important to understand the operator precedence and how parentheses are important, because you could potentially end up with a result that you may not want to end up with. That's why I was showing examples arithmetically. And that's the bottom line. I think to master operator precedence and to master the order of operations and to master the various types of operators, it means that every time you write an expression, for whatever reasons you write it for, that might involve a mixture of arithmetic, logical, and relational operators, that you get the result that you expected to get, and not something different, because you become the expert. You become the one that needs to make a mathematical expression or a logical condition into a series of operators in Python, for instance, Python syntax. I don't want to say much more than that. I don't want to complicate things. We'll exercise this a lot more next week, but the minimal thing you want to go into next week is those 3 classes of operators, and then the order precedence, the order of operations that take place when you start to mix those together. We've got to have that down for the next unit.
All right, well, that's great. I think I'll give people a chance for a question. I think we have one question out there that may or may not have been answered, but for everyone to know, again, thank you very much, Dr. Sack. Everyone, this is an ongoing series where we talk about a discussion of a self-paced course that you can go start now on Saylor.org called Introduction to Python. Obviously, you can go to our discourse forums. All of this will be available in perpetuity. Replit is the program you're using, correct?
Yeah, that's the development. It's online. It's an online
It's
development.
Online. It's in the chat. I'll make sure it's in the description if you're watching late. The one question I had, which you might have touched on, because I think we had got a couple minutes, and you said it's not really touched on in this course, but someone asked a question about the bitwise operators, which is at some point someone's going to Bart Simpson me, and I'm going to be Moses. Someone asked if you could. So I got a minute or two, maybe if you talk about that, maybe just a little bit, if people are curious.
So let's make believe you have a 64-bit computer, okay? And in a so if you have 64-bit integers, I'm not going to write out all 64 bits, but I'll just let you know that for, let's say,
we don't have the time.
Say again?
We don't have the
time, right? Exactly. Right. But I'll be like 0, 0, and then all the way down to the binary representation of, let's say, a 5, and then 0, 0, all the way down to a binary representation of a 7. And just like you would align numbers as if you were going to add them or subtract them, if I wanted to perform, let's say, the logical AND between these two numbers, they're performed bitwise, bit by bit. So just like you would add numbers down a column or subtract numbers down a column, if that's the algorithm that you use for addition and subtraction, all you have to do basically is compare the bit representations in each position and then use that rule I talked about. Let's say for the AND, if you see 2 1s in a column, you get a 1. Otherwise, in all other cases, you get a 0. So 0 ANDed with 0 gives you a 0. 1 ANDed with 1 gives you a 1. 0 ANDed with 1 gives you a 0. So you could say, okay, and this only becomes, it's not obvious if you do this, if you write out the code to say 5 and 7 like this is equal to 5. That's the result that you would get if you did this in Python. And what's taking place is a bitwise operation. Now, unless you understand the logical operation, it's not clear why this would be true. If you were to OR them, then the rule for the OR, instead of using the AND, if you were to OR them, then and you AND those guys together, then you would get a 1, 1, 1 with a whole string of zeros afterwards. So 5 ORed, this is what we're predicting. I'll do this in a second on the screen. 5 ORed with 7 is equal to 7. Okay. So all that happens is you take those logical operations and you perform them bitwise. Okay. For shifts, you're shifting bits either to the left or to the right. That's what those double arrows do. They'll take these, and actually, if you, I don't want to go, we got like a minute left. Okay. And actually, the triple
you don't
integral.
have to, as we said, not covered in this specific course.
Yeah, but anyway, let's just put the brakes on here for a second. If I were to say something like 5 and 7 like this, then based upon that bit representation, Python, run window or whatever, that we should go ahead and get that, we should get that 7 back. Now it's giving me a 5 and it with 7. It's giving me a 7 back. Let's just see this in slow. Oh, I'm sorry. It is 5 and 7. That's true. But we have to use the ampersand for the bitwise operation. So 5 ended with that is 5. So the bitwise operation. So the ampersand is the bitwise version of the AND operation. The up and down line is this. So under those circumstances, if you were to OR them, you would get a 7 back. So the syntax for the bitwise operations, they correspond to the same operations, but they don't, but they're done bitwise as opposed to trying to like AND or in the way that I just showed you, which again, you could do with, unfortunately, you can do those with integers as well. But you got to understand that I'm not going to forget, I'll stop there. But the point is that for every Boolean logical operation, there's an equivalent operator that you can use for bitwise operations. So I could do something like this. I could say 5 left shift by 2. That's the last thing I'll do. And if I go ahead and do this, then you'll get a 20 out because you're shifting those bits by 2 to the left. That's what that double left means. And when you shift it to the left, basically a left shift is like multiplication by 2, and shift is like an integer division by 2. So when I say shift that 5 by 2 bits, it means take all those bits and shift them over to the left. And you can demonstrate to yourself that actually is a binary 20, which is equivalent to taking 5, multiplying it by 2, and multiplying it by 2 again, because there would be 2 shifts. So that is the fastest introduction to bitwise operations that I have ever given anybody on earth. But the idea is that in order to use those operations, you have to understand what the bit representations, what the base 2 representations are. For the integers, for the integer representation. So again, if you get into floating point, it's a different ball game altogether. I'm just talking about integers right here, integer representations.
Eric, I think that was fantastic. We should probably clip that out just as like its own thing for people for the fastest introduction that you could possibly have.
Sure. That'll be like another course. Take those 3 minutes.
Again, as always, Dr. Eric Sack, thank you very much for doing this. We'll be back next week. 9:30 Wednesday, 9:30 Eastern. And everyone, again, you can come to sailor.org. You find the Python course there, CS 105. All these links will be in the description. Thank you, everyone, for joining us. Thank you for your questions. Feel free to add questions in the comments. If we have something we need to come back to, we can maybe come back to it next week at the beginning as a refresher. But thank you, everyone, for joining us. And again, thank you, Eric, for being here. And thank you, everyone, for being in the chat. And people are saying very nice things right now in the chat. I thought you did a great job. Everyone, have a nice day. We'll